All right, that was the main lecture in example 1. Remember, the idea was do the opposite. So now I'm going to solve these examples here. I'm going to switch to black. So remember the first rule on solving anything with these little houses, these radical houses, and this is a cube root. You got to get it by itself first. So this -1 is not belonging here, and so what we're going to do is we're going to add 1 to both sides to get rid of it. And again, you can write your equal sign, make sure those stay mostly lined up. 2 plus 1 is 3. This gets canceled out right here, and now we are left with a cube root of 4x minus 13, which is no big deal. Now, don't panic. Oh, my God, cube root. Oh, my God. No more panicking. Remember, all you have to do is identify the opposite. What is the opposite of this? The opposite of cube root is cubing. So then you cube it on both sides. That removes the little house. And see, this is why I do the line, because my spacing is terrible. 4x minus 13. If you're wondering what line I mean, I'm talking about this line. 4x minus 13 equals, what is 3 cubed? 3 times 3 times 3 is 27. So 27. Now I'm going to add 13 on both sides. I'm going to add 13 on both sides, and I have 4x equals 27 plus 13 is 40. Divide out that looks like a 46, divided by 40. Divide out the 4 on both sides, and you have x equals 10. And you're good to go. All right, moving on to the next example. Okay, this one, y'all pay attention to the way this looks. You see this? The only thing in the radical is the actual x. So I've got to get rid of my plus 2, and then I have this dividing thing I have to do in a second. So this says 2 times the cube root of x plus 2. So like any equation, the first thing we're going to do is we're going to get rid of the addition and subtraction parts first. So I'm going to subtract 2 on both sides. And again, that's an old rule. That's not new. That's not new math. Recall it from your old solving equations. You're good. All right, this is the next step. This says 2 times all this garbage. 2 times all this garbage. So what's the opposite of times? Dividing. You simply divide it out, and you end up with cube root of x equals 5. So this is not that bad. To get rid of this cube root, remember the rules. You do the opposite. You do the opposite. And the opposite of cube root is cubing. I end up with x equals 5 times 5 times 5, 5 times 5 times 5. Yes, they look like s's. Shut up. Equals 125. So now my answer is 125. Are you supposed to go back and check it? Yes, you are. I don't want to check it right now in these notes, but go back and plug it in. I can tell you from looking at this that yes, this comes out accurately to 12. This works. Going down to the next one. Okay, this is a fun one. And here we go. This says 5 plus all this stuff, yada, yada. Whenever there's nothing in front, y'all, remember, you can assume there's a positive. It's a positive 5. So what I need to do is I need to get rid of this positive 5, and I need to move it to both sides. Yeah, that's that. Cross it out, and I am now left with 7 minus 5 is 2, and I'm now left with 1/2 cube root. That's a terrible 1/2. 1/2 cube root of x plus 3. Now, this is something I'm going to switch colors. I've taught this, but I'm going to keep teaching it till y'all get it down. This says 1/2 times all this stuff. This says 1/2 times all this stuff. So the opposite of that is dividing by 1/2. That means I want to divide by 1/2. That means I want to divide by 1/2. But remember the rules of fractions, y'all. The rules of fractions, and I'm going to do it right above here. The rules of fractions state, and I'm going to make up a problem. If I had 5 over 4 divided by 1 over 2, and check it out, look down here, we're dividing by 1 over 2. What ends up happening is that whole thing of that KFC, keep, flip, change. So you keep the 5/4, you change the division to multiplication, and you flip the fraction. So what ends up happening when you divide by a fraction is you actually are going to multiply instead. And so even though I have divided by 1/2 right here, and you can see that, what actually ends up happening is I'm going to be multiplying by 2 on both sides. So they're the same thing. They're the same thing. I'm going to be multiplying by 2 on both sides. And what happens is 2 times 1/2 cancels out to 1. And then I am now left with the cube root of x plus 3 equals 2 times 2 is 4. And if you don't believe me, go to Desmos and type in 2 divided by 1/2. Go type it in and you'll see the answer is returned as 2. I mean, as 4. Anywho, with that said, I'm going to keep going on to the next step. It says cube root. Guys, pretty simple. Get rid of it by just doing the opposite. X plus 3 equals 4 times 4 times 4 is 64. Minus the 1 on, or the 3 on both sides. And you get x equals 61. And we're done. You can plug it back in to check it. I don't want to. It does work out perfectly fine in this example, does it? 64, 8 times 4. Oh, no, it doesn't. Let me push pause and look at this for a second. Hold up. All right, I just paused it and I'm coming back. Yes, if you plug in your 61 into this, you'll check it out. I guess I'll do it. Let me switch colors first. I'll at least show plugging it in. Get rid of that. 5 plus 1/2 cube root of 61 plus 3. Does it come out to equaling 7? So 5. If I have 5 plus 1/2 cube root of 64, does it equal 7? The cube root of 64 is 8 times 1/2. See, I keep working this wrong. Hold on one second. What? Okay, so I keep stopping and pausing this because I keep trying to take the square root of 64. I keep replacing with 8. And I'm like, what are you doing? It's not 8. So even I will make those mistakes, y'all. So 5 1/2 times, what is the cube root of 64? It's 4. Cube root of that is 4. 5 plus 1/2 times 4. 1/2 times 4 is 2. Yeah, sorry for that clunky finish, but you'll live. With that said, yes, that's how you check it. I would recommend plugging it into Desmos so you don't make the dumb mistake I just did. Good luck.